Sri Gurubhyo Namaha. Welcome to online class, children. Today's class we are going to learn about the properties and the types of coordination complex in coordination chemistry. First, we are going to learn about the properties of coordination compound. So, the coordination compounds are formed by the transition elements. So, transition element due to the presence of unpaired electrons. Already you know that the presence of unpaired electron will play an important role in an element. It can conduct electricity as well as heat energy, and in the compound, complex compound, due to the presence of unpaired electrons, they can be colored. Understand? Due to the absorption of light during the transition state. So, the transition element has incomplete d orbital. So, they can be promote from lower energy level to the higher energy level during the excitation state. In the transition, they absorb the light in the form of energy. After that, they are coming back to their original position. They are emitting the light with the color, with the wavelength of the particular color. So, due to that, they can give the color. So, due to the presence of unpaired electron in the coordination complex, they can give the colored compound. For example, iron 2 compound. The iron 2 compound can give green and pale green color, and due to the excitation by the oxidation loss of electron, it become what? Brown and yellow. So, due to the presence of unpaired electrons, the coordination compound can show colored compound. And next, and the coordination compound, the center is going to be coordinated with the central metal atom. The central metal atom is nothing but the transition metals, and the the coordination complex also, or the coordination compound, or magnetic property due to the unpaired electron. Now, last property, due to the coordination compounds are colored due to unpaired electrons, and here the coordination compound and the metals present in the coordination compound has unpaired electrons in d orbitals. So, for that they can attract by the magnetic field, so they can show what? Magnetic in nature. And next property, the chemical reactivity. So, the chemical reactivity is going to be the variety of chemical reactivity, because there are two things, unionizable ion and ionizable ion. So, the electron is going to be transferred, the electron transfer inner sphere for and the outer sphere. Now, for example, K4 FeCN6. So, this is going to be ionized with K plus and complex FeCN6 4 minus. So, here the bond between the ion and the ligand. So, the inner sphere. So, the electron are going to be transferred in inner sphere, as well as the electron is going to be, now there are two parts. One is the electron transfer inner sphere and the electron transferred in outer sphere. So, this can be exist in the outer sphere of the coordination compound. So, in the electron transfer in coordination compound is going to be taking place in two different way, so that they can show the catalytic property. So, due to this transformation of electron in two different way, so most of them are most of the element or molecules can show what? Catalytic property, as well as they can all the stoichiometric manner. And next property of coordination compound, and next one is the double salt. So, what we have that in the coordination compound also an array, a row of ions or molecules, or the compound is going to be arranged, but the ionization is going to be different. So, the some of the unionized part in the coordination compound, but if you see that in double salt for example potash alum K2 K2SO4 Al2SO4 thrice 24 water molecules. So, here they can be dissociate into respective ion in solution, but in coordination compound in the solution, in aqueous solution, there is two part, one is ionizable part and another one is non-ionizable part. So, here now you can see this is going to be dissociate into K plus SO4 minus and Al3 plus and SO4 2 minus like this. So, they can dissociate into individual ions. So, the double salt contain two cation, aluminum as well as potassium and anion sulfate. This is the double salt. So, this is the difference between the double salt and the coordination compound. So, the coordination compound can be ionized. It can be ionized in two different ways. One is within the coordination compound, one is the ionizable part, another one is non-ionizable part. And then the coordination compound, now you can see this here. In the double salt it is going to be ionized completely. In the coordination compound, for example K4 FeCN6, this is going to ionized into simple cation and the complex anion. This is the ionized part and this one is non-ionized. So, here the iron and cyanide cannot be dissociate into ions, or they are not undergo the ionization as Fe plus and Cn minus. So, in the coordination compound, that is the difference between the double salt and the coordination. So, the array of an molecules or ions are arranged or atoms are arranged in a compound, but in aqueous solution the ionization is going to be different from double salt. This is one of the property of coordination compound. And then the types of coordination compound, the types. So, based on this, the cationic complex and anionic complex. Already we learned that in the ionization, one is ionizable part and another one is non-ionizable part. Based on that, now for example, now hexaamine cobalt 3 chloride. This is the name of the compound is hexaamine cobalt 3 chloride. This is going to be ionized into cobalt hexaamine 3 plus 3Cl minus. So, here what is this complex? The complex is found in the form of cation, so that it is called what? Cationic complex. So, in this case the complex is going to be ionized as complex cation and simple anion. Complex cation and simple anion, so that this complex is called what? Cationic complex. And then anionic complex, K4 CuCN6. So, here this can be dissociate into K plus and CuCN6 4 minus. So, in this case the compound is going to be ionized into simple cation and complex anion. Here the unionizable part in this is the copper and cyanide are not ionized, because it can be found in the inside the coordination sphere. So, the complex is with the negative charge, so that it is anionic complex, and here the coordination sphere with the positive charge, so that it is called what? Cationic complex. And next one is neutral. And the neutral, now the neutral complex, nickel tetracarbonyl, the carbonyl is the neutral ligand. So, there is no charge for the carbonyl. So, here the nickel can exist as zero oxidation state. In this case, the nickel exists as what? Zero oxidation state. So, that it is called a neutral complex. It is called as what? There is no what? Cation or anion in the coordination sphere. So, the ligand present or the ion or the molecule present in this compound or the coordination compound is neutral. So, that they can form what? Neutral coordination compound, neutral complex. And the polynuclear complex. The polynuclear complex, here the already the complex is made with the, which one is the main thing is the central metal atom of transition metal. Here the bimetallic complex, the two central metal atom can make a bridge between the atom and form the complex. Now, Mn2CO8. So, here that the bridge is going to be formed between manganese and the bimetallic complex. Understand? So, here the bond between the central metal atom, and then each metal ion can have a bond with here CO and CO. This is the now you can see that in the complex Mn2CO8 octocarbonyl dimanganate. So, here M and then so the compound. So, already we learned that the two different way the electron is going to be transferred, one between the inner sphere and another one is outer sphere. In the bimetallic complex, the compound in the electron is going to be transferred between one the central metal atom for the bimetallic complex, as well as rhenium octochloride with the dirhenium. So, they can form what? The bond between the metal ions and then the ligands or the ions present in the coordination complex. So, that they are called what? Polynuclear complex. It is called as what? Polynuclear complex. And next we are going to learn about the homolytic and heterolytic. Homolytic based on the types of ligand. Homo means similar, hetero means different. If the coordination complex with same kind of ligand, the ligand can be classified as positive ligand, negative ligand and the neutral ligand. And here you can see that the homolytic complex, the coordination center is bound with only one type of electron pair donor, that is the ligand group, only one kind. So, in this case you can see this CuCN. So, which one is the ligand? Cn, the only one type of ligand. So, this the cyanide alone is going to share the electron with the central metal atom copper. And then you can see some other example also. So, here also only one molecule, ammonia. Ammonia is going to share the electron with the central metal atom. So, the only one, so what is here, that only one type of ligand is going to share the electron with the central metal atom. So, that the complex is named as what? Homolytic complex. And then heterolytic complex, more than 2. So, the central metal atom is going to be bound with different types of ligand. In the heterolytic, the central metal atom is going to be bound with different types of ligand. So, that it is called hetero. Hetero means hetero, different. Homo, same. So, the same type of ligand is going to bound with the central metal atom. So, that it is called homolytic. Here the hetero, different. So, in this complex, see that cobalt tetraamine, dichloro cobalt 3. So, in this complex there are two types of ligand, amine as well as chloro. So, this one is neutral ligand, and this one is negative ligand. So, here in this complex the central metal atom is going to share the electron. The central metal atom is going to share the electron between two different types of groups. One is amine and another one is chlorine. So, these are all about the types of complex and the property of complex. And the next class we are going to learn about the naming the complex. So, in the next class, the next video, you are going to learn about the naming the coordination complex. So, thank you for watching this video. To receive our online lesson, please press the subscribe button. You will receive the latest update. Thank you.